Well, hello and good morning, everybody. We're probably starting a little bit early today, maybe 1 minute early. Thanks for everybody joining me this morning. It's quite good to see that you must have all gone to the early church service on this Easter Sunday, because so many of you are joining me today. So it's very nice to see you anyway. I assume we are actually working, although I can see my camera is bouncing around a little bit today. Sorry about that. Let's just see if we can just stop it blowing in the wind. Okay, so we've got a little bit. I'll tell you what, we'll start off by just going through the roll call. So got Cody's here. Hello, Paul. Nice to see you this morning. Michael, George, Christoph is in the room. Colin, try not to fall asleep today, Colin. Benji's here. Benji's good to see you, Benji. Didn't manage to get stuck on any escalators today. I can see I've got one of my old friends, Steve here, Steve Tickle. Bit of a story there. I actually posted today's link on my main Facebook account. I've absolutely got no idea how you drive this Facebook thing, so we might have a few people that we don't normally see here today, but I'm sure we'll make them welcome. But it's nice to see you, Steve. Been some years since I've spoken to you. Oh, and Steve saying good morning from France. Well, that doesn't really surprise me. You enjoy your day in France anyway. Oh, we've got another Steve, old bloke if I Steve. Got Radio Cruncher in the room. Good morning, Graham. We said hello to Benji. We've got Rob Tiveridge. Hello, Rob. We've said hello to George. We've got Northern Rambler. We've got Victor. And we've even got Defpom. We've got Scott all the way from New Zealand. So a very warm and good morning on this Easter Sunday, isn't it? Oh, and hello, David, just sneaking in under the wire. Almost late, black mark next time. Okay, so this is a bit of an impromptu live. Everybody's coming in. Hello, Ian. Yeah, hello, Ian. All the way from sunny Scotland. I don't think it does ever get sunny in Scotland. If it is, I've certainly never seen it sunny. Oh, Harb's Electronic Lab. God, you're all coming in today, and I can see you're all desperately trying to avoid going to church. I think that's probably what it is, isn't it? Right, I'll go again. So what we're going to do today is, it is an impromptu live stream. Had quite a lot going on this week. I suppose I might as well tell you, actually, because it's not a secret. Unfortunately, my father passed away a few weeks ago. So it was the funeral on Tuesday, and obviously that was a bit of a sad affair, but yeah, what can you say? These things happen. It wasn't unexpected, so it wasn't a shock. Got to say that one thing that did happen is that the actual pallbearers at my dad's funeral were 4 very young and sexy young ladies. I'm not sure if I could say sexy. They were actually fairly filthy looking. My dad would have really appreciated that. So that was, I thought, a nice touch. So yeah, so my father has passed away. He's been buried. The funeral is over and done with. But as you can imagine, this week has been a little bit of a strange one. And if you've ever had to deal with kind of the death duties when somebody passes away, you'll know that there's quite a lot of things to organise. It certainly was a bit of an eye-opener. So I've been very busy doing that, as you can imagine. So I really didn't have time to put together a proper video for you. But I thought what I would do instead is a bit of a Sunday morning coffee shop, really. I've kind of jokingly called it the Sunday morning service, haven't I? I just thought we could all get together. I know that some of you people use these shows and live streams, my live stream and Graham's live stream, who will be on later. I know some of you use these live streams as kind of gathering posts just to catch up with each other and say hello. You might not be that interested in what's happening on the bench, but yeah, you just come together and you chat amongst yourselves. That is absolutely fine. Please feel free to chat in the background. Chat about anything you want. I'm not going to say it's got to be about vintage electronics. As long as you're enjoying yourself and being respectful to one another, that's absolutely fine with me. So feel free. So today what we're going to be looking at, well, what's really brought this on is that I don't know if, well, I know that some of you've got wives at home. Well, I buy stuff on eBay and I let it pile up into the hallway, and it will stay there for quite a while as my wife gets more and more upset. Oh, morning, Robert. So this equipment I buy from eBay, it starts to pile up in the hallway, and a little bit like Jenga, it actually forms a critical mass at some point, when my wife will just explode and read the right act to me. And that's what really happened yesterday. She said she was sick of walking around all these boxes in the hallway, and that I needed to unpack them and break up the cardboard, create some space. And of course, she's absolutely right. Some of these things have been sat in my hallway now for, well, I think one of them's been for 3 years. So yeah, you can see that I really did wear out her patience there. So one of the things we're going to take a look at is a stereo modulator, which basically creates a stereo signal that can be transmitted. It's used as a piece of test equipment. So that's one item we're going to look at today. I don't actually know anything about FM stereo because all my work with radio in the past, it's all been to do with AM, because I'm interested in old communication receivers and they're predominantly AM. So I know pretty much nothing about FM and even less about stereo. But I was hoping we could have a go together at setting up this stereo modulation. I was hoping we could have a go together at setting up this stereo modulator and seeing if we can get a tune out of it. I've got no idea if it will or not. Don't even know if the things work. It was bought on eBay and it's been sat in a box for 2 years, but we'll have a go. I think we've got some people come in the room. Hi, Fred. Nice to see you. I hope you're not doing a 12-hour live stream. No, I think not a 12-hour one. I think Scott holds the record for that. Although I think maybe Graham Radio Cruncher, he's maybe done a 12-hour live stream. I'm not sure. Maybe Graham can say what the longest live stream he's ever done is. Certainly, I was watching Scott's live stream. I don't know if it was Saturday or Friday night, but I was watching it in the evening. I went to bed, woke up in the morning, and Scott was still live streaming. So the same live stream lasted, I think it must have been more than 12 hours, and he still hadn't fixed it. So there you go. Sorry, Scott. Yeah, I'm not going to call anybody for not fixing things, because some of you saw my attempt at fixing the solitrons. It was a bit of a disaster, wasn't it? I don't think I was quite ready. I wasn't ready for that level of complexity. I was hoping to grab the low-hanging fruit of a poor power supply, but it looks as though it's not going to be an easy fix. But I think we will have a go at those solitrons in the future. But I'm going to take my time with them, maybe do some of it on camera, some on camera, don't know. As I said last time, some of these repairs, we're like doctors, aren't we? If it doesn't go well, we bury them. We bury our patients. So yeah, something like that. Right, okay, I've waffled on. You lot can talk amongst yourselves, and we will go for the first item on the bench. And I think we'll get the small items out the way first. Right, okay, so we've got a cardboard box, quite heavy. I'm just trying to, I've got no idea where it came from, this. Okay, well, rather topical, because this one came all the way from Ukraine. Now, it has actually been sat in my hallway for about a month, but it kind of shows you that even in times of war, nothing holds up the postal service, doesn't it? So this first item we've got today is something from Ukraine. So let's carry on with the unboxing. Now, I'm sure that a lot of you know that are interested in vintage electrical equipment, vintage electronics and radio, that when the kind of Soviet Union collapsed, and all those separate states went their own ways, for whatever reason, an awful lot of Russian equipment, army surplus, if you like, it all ended up in the Ukraine. And, well, you can buy lots of things from the UK. Famously, a lot of us buy germanium transistors, Russian germanium transistors. A lot of them come from the Ukraine, but also various other electronics equipment, army surplus, and just various surplus electronic stuff all comes from the Ukraine. It's saying don't lick it. No. Well, actually, you might raise a good point. I wonder if I should put some gloves on. Have I got any gloves to hand? No, I'll man up. We'll be fine. Do I need to move the? I think I need to move the camera down a bit. You don't need to look at my face. So this is the first item on the bench today. Let me move the camera down. Definitely, I think Paul's advice there of don't lick it. Oh, is it ticking? No, I'm not going to put my head too close to that. So first thing I'm going to do before I risk electrocuting myself is, let's get a screwdriver. So what we've got on the bench here is a capacitor, and it's a little bit of a special capacitor in that it's 1 microfarad, so it's not a very big capacitor, is it? 1 microfarad, that's rubbish, isn't it? However, it's 1 microfarad at 6,000 volts. So yeah, that can potentially hold quite a lot of energy. Has anybody got a calculator? Half CV squared? I think it's half CV squared, isn't it? Perhaps somebody can do the math, how much energy that will store. If we charge this capacitor up to 6,000 volts, what will the total energy storage be? Go on, somebody type it into a calculator. I think the calculation's half CV squared, isn't it? Oh God, you're all getting scared. Whenever I mention maths, half of you just disappear like cockroaches when the light comes on. You'll be fine, don't worry, use a calculator. So what we've got today is a Russian high voltage capacitor, and it's a paper capacitor. I'm not being smart, it says on it. It's a paper capacitor, which I did know, and it's a pulse capacitor. Now, for those of you who don't know what a pulse capacitor is, what that basically means is it's designed to discharge it's designed to discharge itself very, very quickly. Some capacitors are designed to be discharged relatively slowly, maybe things like reservoir capacitors in a power supply, but you've got certain applications where you need to get all the energy out of the capacitor very, very quickly. Now, it can be a problem if, for example, if you were to short out a capacitor, a normal capacitor, what can happen is that so much current can flow, and it can be in the thousands of amps. You get thousands of amps flowing within the capacitor, and what that can do is it can burn off, it can just disintegrate the bond wires which are used to form the capacitor. So you've got to be very careful. You know, you see a lot of people, and even I've done it, you know, we work on vintage electrical equipment, we run it up, and then the first thing we do before we put our hands in it, we discharge everything. Now, if you're a bit slack like me, you probably just get a screwdriver and you short the capacitor out to the chassis. You absolutely shouldn't do that. You shouldn't do it because you risk damaging the capacitors. However, 18 joules, thanks, Steve. Yeah, so 18 joules. So yeah, that's certainly more than enough to stop your heart multiple times. What was I going? Yeah, I think I was talking about the fact that if you discharge a capacitor quite quickly, it can do quite a lot of damage. So you shouldn't jam a screwdriver across them. Really, what you should use is a large wire wound resistor, maybe a few K resistor. And what you're going to do is you're going to limit the amount of current that you pull from the capacitor. It's still going to discharge. It is going to discharge slightly slower, but it is much, much kinder to the capacitor than just ramming a screwdriver across it. However, this capacitor being a pulse capacitor, it's actually designed so it can dump all its energy instantly. So we can actually allow very high currents to flow from this. Now, this capacitor has been shipped with me, and you can see that both the terminals are actually open, and you know, I still don't really trust this. Really, what you should do, or what the seller certainly should have done, you should never send high voltage capacitors like this, because what's been known to happen, in fact, people have been killed. Even leaving a capacitor on the workbench like this, you can actually get just wind, you can get a breeze of air which blows across the terminals of the capacitor, and it has been known for capacitors just to self-charge. The other thing you can get is, I forget the word, somebody's going to correct me if I get it wrong. It's not dielectric reforming, it might be dielectric memory. What you can get is, if you charge a capacitor up to a few thousand volts, you put your screwdriver across it and you discharge it. take your screwdriver away again, if you just leave the capacitor there, it will actually recharge to some extent. Now, if it's a small capacitor, that won't matter. It doesn't matter. But this capacitor, the fact it can recharge itself up to multiple thousands of volts, if you could come along weeks, years, days later, 10 minutes later, put your hand across it, well, certainly if you put your hand across it, that's going to be painful, probably not lethal because the current is going to flow across my hand here. But you could have situations where one of the terminals is referenced to ground. I put my hand on it, the electricity is going to flow straight up my arm, across my chest. In doing so, it's going to stop my heart, and my wife is going to find me some days later being eaten by cats. So yeah, so really, whenever high voltage capacitors are being shipped, it's kind of mandatory. It's not a law, but anybody who's got anything about them, dielectric absorption, that's probably the word. Dielectric absorption. Really, when you ship a high voltage capacitor like this, you should absolutely strap out the contacts. And in fact, not just when you ship it, even storing it in the workshop, you should have the contacts bound, shunted together. So now a charge can't build up in here. Oh, hello, Dave. Nice to see you. So the other reason you want to be probably a little bit careful with this is because it says that it's a paper and oil capacitor. One of the questions is what type of oil is in here. Some of these oils were extremely nasty, cancerogenic. I think that the word was it PCBs? PCP? I think it was PCBs, wasn't it? Polychlorinated something or others? I don't know. Basically, the oil can be very toxic. It can be the same sort of oil that's used in transformers. Certainly, there was a big thing back in the, I think it was the 80s in the UK, that there was an awful lot of warnings and shock stories. Certainly, people were making claims against the electric generating board because they thought they could have been exposed to these chlorinated, I don't know if I can say that, polychlorinated biphenyls. I thought they were flowers, biphenyls. I don't know. Polychlorinated biphenyls. Basically, they are bad news. And I think one of the things about these polychlorinated biphenyls is that, what do they call them? Again, I've forgotten the name. I'm not doing very well today, am I? Basically, once these chemicals get into your system, they stay there. You can't excrete them. So yeah, they become locked onto your body. I think some of them bind with the calcium in your bones. And once you take these nasty chemicals into them, like a lot of things, if you drink some poison or something, yeah, if it doesn't kill you, you're going to piss and you're going to poo it out. You're probably going to be okay. But certain chemicals will build up in your system, just becoming more and more toxic. And that's certainly the case with these PCBs. So yeah, so really you want to look for any kind of oil or anything leaking on here. And I think really the honest answer is, when I finish playing with this, I'm going to go and wash my hands anyway, but I probably shouldn't have been touching it without gloves on. So I'm sure most of you know about that, things like that. So this is a high voltage capacitor. We will try and test this in a minute. I don't think we'll put 6,000 volts on it. I'm a little bit worried that if we charge this up to 6,000 volts and we discharge it, I think it's quite likely that the electromagnetic pulse is going to take out my computer. Certainly, I charged up another capacitor in my bench a few weeks ago, and I think I did post it on YouTube. That was a small capacitor. In fact, let's get that. I actually thought that this was quite a big capacitor at the time. So this capacitor is, well, it's 1 microfarad at 4,000 volts, whereas this capacitor next to it is 1 microfarad at 6,000 volts. So I guess you can see it is quite a lot bigger, isn't it, for a relatively small increase in voltage. I'm guessing that's something to do with the dielectric strength of the materials. It probably has a square involved, so probably even a slight increase in voltage requires quite a big increase in the insulation between the capacitor plates. I'm guessing it could be something like that. So yeah, so this is a 4,000 volt capacitor. Again, this is also a Russian one. I think it is. Yeah, it's Russian, but I bought this actually brand new old stock, but this did actually come with the terminals strapped out. Anyway, what I was trying to say is I did charge this capacitor up on the bench a few weeks ago, and I put a screwdriver across it because that's the showman thing to do, isn't it? It's a bit more exciting than discharging it. And it went with an enormous crack. And of course, what that does, it lets out an electromagnetic pulse. It's a magnetic pulse, and that magnetic pulse will couple with equipment in the surrounding area. So one thing it did is I've got a computer it's literally under this bench, and it's the one that we're streaming on at the moment. When I shorted the computer out, when I shorted the capacitor out, the computer went off, it restarted. I also had some voltmeters, I have this flute meter. Again, if you watch the video, you'll see that I was using the flute meter with a high voltage probe. And even though the flute meter wasn't in direct contact, it was kind of like this distance away. When I actually shorted out the contacts, the flute meter, it actually reset itself. Oh, good morning, Vintage Electronics Repair. Good morning, Andy. So the electromagnetic pulse actually caused the digital voltmeter to reset. So the mechanism that gives rise to that is what will happen is when you actually short out a capacitor, a very high current will flow across the piece of wire that you're doing the shorting out with. And a very high current will flow in the piece of wire. Now, as you know, if you put current through a wire, that gives rise to a magnetic field around that wire. Now, because the current is so high, probably in the thousands of amps when you discharge something like that, the magnetic field that it gives off is relatively quite powerful. And what happens is that magnetic field, it will hit the meter. It will hit the meter on my bench. And of course, we've got coils of wire. We've got printed circuit boards in here with tracks on them. So that magnetic field will then get converted back into electricity, much like a generator does. And some of these lines some of these tracks will be leading to things like the processor, maybe the reset lines. So what you'll be doing is when this magnetic pulse hits the DVM, the processor will just get very confused because, it might not even be the tracks. These magnetic fields could actually couple with the actual silicon substrate itself. Anyway, the meter gets confused and it resets itself. So yeah, so the point I'm making is, as much as I would like to on this live stream put a screwdriver across here, we might not be able to do it. Maybe we shouldn't do it because everything might go off. We'll take a vote on it. Maybe we'll do it at the end, and then if everything goes off, it doesn't matter, does it? Should we do it at the end? Give me a thumbs up if you want to see us discharging this 6,000 volt capacitor live. We'll do it. Right, okay. I guess the first thing I want to do though is actually let's check on the capacitance value. So we have got it strapped out. Let me get my DR meter here. Go for it. Yeah, everybody's going to give me a thumbs up. Yeah, let's discharge 6,000 volts. Yeah. Okay, so we're going to have a go with the. Oh, I always say this wrong as well. The DERE meter. Oh, turned itself off. Knowing my luck, the batteries will be flat. I think we got a reading then, didn't we? Can you see that? So we're actually measuring 965 nanofarads. So that's pretty close to 1,000 nanofarads, which would be 1 microfarad. So we're in the ballpark there, aren't we? But yeah, it's not quite on specific. Well, it'll be within the tolerance, won't it? 965 nanofarads will be within the tolerance for this capacitor. Would have been nice to have a little bit more, wouldn't it? So that's the first item today. I haven't told you what I was going to use it for. Right, okay. What I want to build is something called a surge generator. So surge generators are used in EMC testing. What frequency? Well, I don't know what frequency the DR was set to. No idea. 1 kilohertz, Scott. So what am I using this for? Oh, we've got I need to put my glasses on. SDG. Oh, nice to see you here today. Uh, um, you throw me actually now. People coming in the room. Yeah, brain's gone. Right. Okay. So what am I going to use this for? Right. Okay. What I want to build with this high voltage capacitor, I want to build a surge generator. Um, So what a surge generator is, it's a piece of equipment which is used for EMC testing pieces of equipment. So you plug a piece of equipment into your mains, and what you can have is you can get a high-speed transient coming in on your mains wiring. Maybe your telegraph pole a few miles away gets hit by lightning, or maybe even the factory next door. They might have a big transformer that gets switched on, or it gets switched off. You get a huge electromagnetic kickback that couples into your mains wiring, and the piece of equipment that you're operating can potentially be damaged by the surge which comes out of your mains plug. Same similar kind of thing that when back in the old days, your if we had a lightning storm, half our modems used to explode because we would get a surge of electricity coming into the wiring and damage things like modems. So, but I actually want to build a piece of equipment which deliberately dumps high amounts of energy into a device under test. Now, there's a couple of reasons I want to do that. Is I would be quite interested to see how some of these meters withstand these high voltage surges. Now, probably won't be using the full 4,000 volts, but I thought it would be interesting to see how good the protection is on some of these meters. So what I want to do is I want to be able to introduce these surges into equipment on the test. I want to see if they can survive. The other reason I want to do it, because I just think it's quite cool just to blow stuff up. Yeah, some of you won't agree. I do. I think it's funny. So I would quite like to discharge some of this energy into various pieces of equipment, see how it deals with it. There's a few challenges in doing that, though. Actually, building the high voltage part of the circuit is relatively easy. There's lots of ways we can easily make 4,000 volts. Some of you will remember that I built my own electrostatic discharge gun a couple of years ago now. So we can easily build step-up transformers or flyback transformers to generate, well, anything from a few thousand volts to tens of thousands of kilovolts. It's not a problem. What the problem is actually discharging all that energy out of the capacitor into the piece of equipment that you're trying to test, and that's a bit of the problem. That's a bit of the puzzle which I haven't quite solved yet, because you need a switch. You need to be able to switch the output from the capacitor onto the device under test. You need to be able to switch all that power. Now, the actual voltage in this case will be up to 6,000 volts. The actual currents involved can be in the hundreds of amps. So things like MOSFETs are difficult to use, MOSFETs and IGBTs. Now, there is ways of using MOSFETs and IGBTs. It usually consists of packing them all together in long series strings, so you build up the breakdown voltage. You couldn't do it with a single MOSFET because the breakdown voltage wouldn't be high enough to withstand 6,000 volts. So what they tend to do is they tend to put a number of them in series. The problem with doing that is the triggering mechanism becomes quite complicated with using triggering coils onto the transformers of these separate MOSFETs. And all that is how it's done on commercial surge generators. If ever you've worked on high voltage equipment like this, and I've worked in high voltage labs and things, before you get it right, you tend to get it wrong a lot. And when you're blowing up MOSFETs at 10, £20 each, because some of these high voltage MOSFETs are expensive, you're going to blow a lot of MOSFETs up before you get it right. And it's still difficult to do. One of the things that makes it difficult is you need a very fast rise time. So I'm looking for a rise time of around 1 microsecond. Again, not particularly easy to do. Now, the early surge testers did actually used to use just simple mechanical switching. I'm not sure how well the outputs were actually characterized, but they did just use mechanical switching. But the more modern units do use solid state switching. I'm guessing really maybe what I should take a look at things like defibrillator technology, because they actually have high voltage triggering circuits in them. But I have had a look online to try to crib some ideas from defibrillator technology, but I've not managed to find any circuit diagrams. But maybe that's what I should do, is buy a cheap second-hand defib, take it apart. Maybe I can use the output stage. I'm not sure. I know that SDG there has done quite a lot of high voltage work, as of some of you others. So maybe maybe you can share some ideas with me on that. So a future project will be to build a high voltage surge generator, and we will destroy some equipment. No, we won't. We'll test some equipment. I shouldn't say that. People get very upset when you say you're going to destroy these things. But before we do anything else, I'm going to just put the strap out links on this capacitor, because nothing's going to happen in the next 10 minutes, but it's just good practice to get in the habit of strapping these things out. And we will try charging this thing up at the end of the video, and yeah, we'll stick a screwdriver across it and see if it goes bang. Right, on with the next item. So I suppose the next item, right, okay, well, you beat me to it there, Steve. So the next item we've got, well, let me unblock it. Let me unpack it first. Oh, let me get a drink. I just see Scott saying that he shouldn't do it to a nice flute meter. Well, from what I have seen of other people doing meter testing, things like flute meters are actually pretty well protected. And to be honest, that's what I actually want to explore. I'm not just looking at blowing things up for the fun of it. You know, we've seen that we can pay, you know, £200 for a flute meter, or we can pay £30 for a Kaiweets meter, which does the same thing. So what are we paying for when we pay that extra £200? Well, one of the things which I believe you're paying for is you're paying for the safety, you're paying for the additional protection circuits which Fluke have put in their meters that perhaps Kaiweets haven't. Bench-made knife. No, it's not a bench-made knife. It's this is a SOG. Probably not legal here. Better not show that. Good job there's nobody watching it. It's not a Benchmade, that's a SOG, S-O-G. Right, okay, so back on subject. So Steve let a word slip there. He said Firetron. Right, okay, so one way to actually produce a high voltage switch, one of the ways you can implement a high voltage switch is actually use a device called a Firetron. Firetrons are quite common, used in industry. They used to be quite common in things like welding sets, and especially some of the things like TIG welders, where I think they used to use Firetrons to initiate some of the HF start. I think Firetrons were also, I believe, used in things like radar equipment because they could switch very quickly. So one of the options is to use a Firetron valve, because Firetrons can handle certainly the voltage. We can get Firetrons that go up to more than 10,000 volts. I'm not sure about the current capacity of Firetrons, though. I'm not dead sure. Now, there is a device which is superior to the Firetron, and again, I'm probably going to mangle it up. I think it's called a Pyrotron. The problem is Pyrotrons, although they actually work an awful lot better, they're used in nuclear triggers. And if you start Googling and looking to import Pyrotrons, you'll probably end up in prison. Or if nothing else, you'll get a knock at the door. Don't ask me how I know. So, yeah, but anyway, I've been looking at Firetron and Pyrotron triggers. One of the things you will notice if you actually look at some of the larger Firetron valves, they actually have very high filaments. They have very high heater consumption. Some of them are actually in the order of, I think I've seen in the order of 10 and 20 amps. They seem ridiculously high. I'm not exactly sure why they are so high, but certainly some of the filament currents are excessive. So I was looking out for a transformer to actually power up some of these Firetron valves that I've sourced. I think I needed about 10 amps for the filament. I believe that this transformer that I've got here, it weighs an absolute ton, and I'm not sure if it's correct, but the guy who sold it reckoned that this was a 30 amp transformer. It had a 30 amp secondary at yeah, 30 amps. I think it's 6.3 volts. I think he's written 6 volts on here. Yeah, I think that's what he's written on here. Yeah, it might be 3.3 volts center tapped. Just looking at some of the wires, which I'm afraid you can't really see. This is the secondary side. Oh, perhaps you can see them. Let me see if does that work. I can actually just about probably get on these wires. We've got to go on the outside of the crimp, but you'll get it near enough. So the actual output terminals on this, the actual thickness of the wire is about 5 millimeters in diameter coming off the output side of this transformer. So that's a pretty good indication that this transformer is going to be able to output a fair amount of current. So I think we've got a center tap transformer with it's a 6 volt winding which is center tapped to produce 2 3-volt windings. I think that's what we've got here. It looks too small for that. Oh, right, okay. Well, I'm not exactly sure. There's no maker's plate on it. No, there is a name. There is a model number on it. It says AC. Strangely enough, AC/DC. Is that a manufacturer? I'm not sure, because obviously transformers really only work at AC. AC/DC 22729. So the thought was that this transformer, if I end up going down the route of using a Firetron to fire off to do the switching for my surge generator, this is the transformer that I'm going to use. The other thing that I'm not sure about, though, and the other thing that's putting me off using Firetron valves, is that predominantly they are low side switching, as you know, most valve applications tend to be, where you have the cathode fairly close to the ground, and you actually have the high voltage connected to the anode side. Well, I don't really want that. Ideally, I want to use high side switching. Now, again, it's not necessarily a problem because you can float the valve. We can actually float the valve on top of the 6,000 volts DC, but unfortunately, then the transformer has to be able to withstand 6,000 volts DC across its windings, or it has to have insulation between the secondary and primary in the casing that would withstand 6,000 volts. So, yeah, it's tricky. So I'm up in the air. I'm still looking for a way to build this surge generator. I wouldn't be surprised if I have to lower my expectations and maybe just homebrew some form of very high voltage switch, some form of high voltage relay. Now, of course, you can buy high voltage relays, but you can't find many high voltage relays, or basically, I haven't found one that can withstand 500 amps. Most of the relays out there, the high voltage ones, will only stand literally a few milliamps. And when you look at the specification for high voltage relays, they often have a rating on them, which is the largest capacitance which you can discharge with them without the contact welding up. They actually give you that value. Certainly, it isn't 1 microfarad at 6,000 volts. So yeah, we're still looking and trying to think of a way to switch this high voltage. I'm trying to think of a way to switch this high voltage capacitor very quickly and dump all the stored charge into a device under test. So that's the plan. Okay, shall we just do a little bit of testing on this transformer? Just want to see if it operates. So we've said that the primary windings on this center tap 6 volts, so we've got 3 volts on either side of the center tap. Just looking at the underside of it, it's a bit of a shame. Let me bring that in. These terminals are a little bit mangled up. Let me see if I can bring you in. You can see that, can't you? Hopefully they'll be okay, but the kind of, the way that they kind of secured to the cardboard, they look as though they're ripping off the cardboard. If we were to wiggle these around too much, I think we'd end up ripping these primary windings off, so we've got to be a bit careful with that. Let me just catch up on the chat with you guys because I've been neglecting you. Sorry, I've been flapping my mouth for about an hour already, haven't I? Oh, Def Pom's drinking beer, good man. It's a heavy metal transformer from down under. Yeah, that's what I see. Paul's making a point about knives there. I went through my Boy Scout training, and I'm sure most of you remember your Boy Scout mottos about being prepared. I've carried a knife since I was probably 10 years old, and now the government says that I'm a criminal. A knife is a massively useful thing to have. It's a very useful thing to carry in your pocket. I use a knife multiple times a day, but because some drug dealers in London are stabbing themselves to death with knives, suddenly I've become a criminal. So you can do what you want. I do carry a small pocket knife. I try to make it legal. You look at the blade length and all that lot. But the reality is, even carrying a knife these days, even carrying a legal knife, can get you into trouble. But the way I look at it is, I'm not going to be caught up in a bar fight with it. It's just, it's not the sort of person I am. I wouldn't, I would never use a knife as a weapon. A knife is a tool, and that's it. But I think it's sad the way that, perfectly, I would say, normal as you can be, whole sections of society have suddenly been criminalised because drug dealers in London want to stab each other to death. I just think it's ridiculous. It really is. Anyway, probably shouldn't talk about things like that on YouTube, but we're here for a chat, aren't we? It's just a Sunday morning hangout. Right, okay, let's just make sure that this transformer is okay and we haven't bought a duffer. Can you see the meter? I think you can. Do you want to see the fluke meter, or do you want to see the new sexy keysight meter? Could use either. I know some of you wanted to see the keysight meter, didn't you? Do you want to see the sexy keysight? Yeah, go on then. Let's get the sexy keysight meter out. Probably see it better on camera, because of course when you're checking a transformer, you really have to know to at least 4 digits what the resistance is of the primary and secondary. We're looking at a Keysight 344618, which is a 6.5 digit multimeter, and it's in the Keysight True Volt range. We need some meter leads, don't we? We'll borrow them off the fluke. I was actually going to do a review on this, but then I decided I didn't really like it that much, so I haven't bothered. And this is one of the reasons I don't like it, the fact that it's spending 20 minutes booting up. Why is it that some modern test equipment just takes so long to start up? It just annoys me. Right, I think we're on ohms, aren't we there? Let's just do that. Okay. Got a little bit of resistance on my meter leads. Can anybody see the null button? Just null that out. I'm sure there's a null button on here somewhere. There it is. God, right in front of me, hiding in plain sight. I think I've all warned you about using null buttons, but a lot of people think that they will remove the error from their readings. Null buttons can actually create an awful lot of error as well. You should be very careful using nulls. However, I'm going to null it out. Okay, so that's just taken away the meter resistance reading. So let's look at we'll look at the secondary winding first. So I'm expecting something relatively low. We've got huge thick pieces of copper here. Right, okay. I wasn't expecting it quite low, actually, that low. I was expecting maybe a couple of ohms. So we've actually got a reading here of, well, 0.01 of an ohm. It is floating around a little bit. That's assuming that this hasn't got short circuit, which I don't think it has. This is just because these wires are just very thick copper. Okay, so we're going to look at the primary now. The primary resistance is going to be a lot higher than that. Unfortunately, we've got two primaries here, which are 110 volts each. And I was going to say, I don't think they're strapped together. I don't think they are. No, they're not. Let's just have a look at the... Well, that's not looking good. Have we got an open circuit primary? I think we could have. No, my mistake. Okay, so 1/2 of the primary winding is just under 2 ohms. We'd expect the other side to be, I was going to say the same, but it's not quite the same. 3.2 ohms. Actually, that's quite an imbalance, actually. Let me go back and measure the original one. A little bit more than I thought. So when you get a transformer like this, which again, it's got two separate windings, you will find that the two separate primary, in fact, it goes for the secondary and the primary windings, you'll find that although you would expect them to be similar in resistance because they've got the same number of turns on them, one of the sets of windings will be wound on the outside of the first set of windings. So what I'm trying to say is, although you've got the same number of turns, because the diameter of the transformer gets bigger as you put more windings on it, you'll find that one of the sets of windings has a higher resistance on it. So that's what the meter's showing us. So we can see that the inner winding here, that's got a resistance of 2.9 ohms, whereas the outer winding has got a reading of 3.3 ohms, and that's because there's physically more wire on one of the secondary windings there. So that's about 6 ohms in total, which is what I would expect for a primary of a transformer. So that looks pretty good. Next thing we're going to do is let's do an insulation resistance test. So to do our insulation resistance test, I'm using this little Samyo meter. I think these are available fairly cheaply. They're about £40. I've got some much more expensive insulation resistance meters, but I actually quite like these. They're kind of cheap and cheerful and do the job. So I've got no complaints. So we're going to use that. Now, Typically, I would do my insulation resistance tests at twice the working voltage of the equipment, um, but I'll quite often exceed that and maybe push it up to 1,000 volts as well, because something like a transformer should be able to withstand 1,000 volts without any problem. So I normally do test motors and transformers at 1,000 volts, but 500 is probably the more normal voltage to do it at. One thing that will make an enormous difference with transformers, and I showed this on one of my previous videos, when you're doing insulation resistance tests, depends how the transformer's been stored. Now, if this transformer has been kept in somebody's shed before it was shipped to me, they actually do absorb a surprisingly amount of water, of moisture into the transformer, and that can really reduce the insulation resistance reading that you get. I did actually have a piece of test gear. It was, I'm sure you remember it, it was the Miles high volt tester. But when I actually purchased that, I actually did do some insulation resistance tests, and the readings looked pretty good. But for whatever reason, when I plugged it into my main supply, it tripped out the earth leakage circuit breaker. And so I took the transformer out of it, and I say the readings weren't low, they just weren't as high as I would have liked. So I took the transformer out of it and I stuck it in the oven downstairs. I stuck it in the oven for, I think it was about 8 hours, set to about 60 degrees, and I just baked the transformer. And once I'd done that, I think what I was measuring originally, I was actually measuring a very high insulation resistance. It was in excess of 100 megohm, which should be absolutely fine for a transformer. But what I found was it was tripping out the earth circuit breaker. So I baked the transformer in the oven, I retested it, and then the insulation resistance was effectively, it was clear, it was in the gigohms. Um, so it just shows you that things like electric motors and transformers, if you're bringing equipment, if you're bringing things out of the old shed, you know, if you've been storing things in your loft or your shed, um, things like transformers can absorb a lot of moisture, and you can have problems if you just plug them in. So I would actually generally say that as a bit of a tip. If you're bringing some vintage equipment into the house and it's been stored damp for somewhere, check it out very carefully. Make sure the insulation resistance is good, and of course, change out that across the mains capacitor, because that definitely will have absorbed moisture, and it will definitely explode. It's something that I've found is that, again, if you have a piece of test gear, you use it regular in your room, it's absolutely fine. But if you take that piece of test gear and you think, oh, I'm not using it anymore, I'll stick it in the garage in the loft, you can guarantee if you leave it there for 6 months, when you come to use it and switch it on again, that reefer capacitor will explode. You can absolutely guarantee it. Whereas if the piece of equipment has just been in constant use in the workshop, the reefer capacitor will be fine. It won't be an issue. It won't just explode. So again, it's all to do with moisture absorption, I believe. That's my opinion anyway. Nylon is surprisingly hygroscopic, yeah. But I think there is a particular problem with those. It is Weaver capacitors, isn't it? Wilmer Weaver, I think it is. There is a particular problem with those capacitors, that the cases on them go crystalline. I think someone call it microcrystalline. Basically, the cases become porous on them, and then they do just absorb moisture into the capacitor. And yeah, when you put your 230 volts across it, rather than being a capacitor, it's a resistance, and resistors get hot, and the damn thing just explodes, doesn't it? Let me just check the chat. Why does it say overload? It just does that whenever you actually, when you're not measuring anything. It just means that when the probes are in free air, just floating, it means that it's not seeing anything. It's outside of its measurement range, so it just display overload. Again, actually, that's one of the things that I find a little bit annoying about it. But no, that's correct. It's not a problem. Might be a 120/230 winding. It is a 120/230. We've got two primary windings, Scott, that if we use this, we're going to have to wire them together. Maplin's. GNU Ninja saying he uses a Maplin meter. There's nothing wrong with a Maplin's meter. What was their range? Was it Precision Gold, the Maplin's meters? I think it might have been Precision Gold. I'm sure that most of us here in the UK have had, or in fact started with a meter that we bought from Maplin's. Although I've got to admit, my first meter was purchased from Tandy. Oh, my cat's making an appearance. Can you hear that? Yeah. Oh, some of my friends that I talk to on Messenger, they're all very familiar with my cat because although it doesn't actually make an appearance in the videos, certainly it can be heard in most of our live Messenger chats. It just walks around whinging about stuff. There was one other range. Was it Blue? I don't know. Am I thinking of Blue Point? I remember Precision Gold in the Maplin's meters, but they were, yeah, they're okay. The Telecat, you are not dead. No, no, no. I think it just comes up in hope. To be honest, yeah, it's just it's playing the waiting game hard. That the cat's playing the long term waiting game. It knows it's only a matter of time before it gets a chance to feast on my eyeballs. Yeah. Oh, white gold SMD version. Precision gold meters from Maplin. Yeah, I think my first meter though, because before, I'm not going to say, was it before Maplin's? I think it would have been before Maplin's, was Tandy stroke Radio Shack. Um, I actually used to work for Radio Shack in the Arndale Centre in Manchester. I'm sure some of you will know Manchester. Well, they used to have a Tandy in there. And one of my first school jobs was working in Tandy in the Manchester Arndale, and it's the only job. Oh no, that's not true. I'm going to say it's the only job I've been fired from, but I've actually just thought of another three jobs that I was also fired from. Um, I was fired from Tandy, and I think the reason I was fired from Tandy is because people were coming in to pay. You would get those little blister packs with 2 LEDs in it for like £5.50 or something, and customers would come in, and I would tell them to go down Oxford Street to the Maplins that was down there and go and buy stuff from there instead, rather than paying £5 for 2 red LEDs. So yeah, that was my Tandy experience. So yeah, I got fired from there. But it was quite a good introduction to electronics, actually. I did quite enjoy that job. But even myself, when I used to work at Tandy, and then in my lunch hour, oh, my wife's just messaging to say there's a cup of tea downstairs for me, so we'll have a comfort break in a minute. So I used to go out on my dinner break from Tandy, and I used to rush down Oxford Street in Manchester to go and buy my electronics goodies, because I've been into electronics for a long time. I think I was introduced to it by my grandfather again in Manchester. There used to be some really old electronic shops, proper old armour surplus places. I think the area was called Shude Hill in Manchester, and there used to be a few of these little rundown shops frequented by smelly radio amateurs. So yeah, we used to go in them shops, and we used to buy your Germanium signal diode and your crystal earpiece, and then you'd get some old telephone wire, and that's that kind of projects I remember, was making my own crystal radios. In fact, me and my friends did a little bit of a crystal radio challenge last year. We all built some little kits and had an evening session making crystal radios. Still a very educational thing, crystal radios, a lot of fun. Everybody should build crystal radios, although not a lot of stations to pick up anymore. Right, I'll tell you what, let's all go for a wee, and I'm going to get my cup of tea, and I'll see you all in about a minute. Oh, actually, it was less than a minute because she left it outside the door, good girl. Right, okay, we are going to just try this transformer, I think. Well, we're going to insulation resistance test it, aren't we? So I'm going to go straight onto 500 volts. And the first thing I'm going to do is, well, I'm actually going to strap, we've got two separate windings on the primary, so I'm going to strap them together. So I just want one continuous winding when I do the testing. So I'm going to strap the two primary windings together to make one long winding. And the first test we're going to do is we're going to test the transformer windings. And we're going to go from each of the windings, the primary and the secondary, and we're going to go to the chassis of the transformer. And we're going to go off these metal lugs here. And the first thing I'm going to do is just make sure that these metal lugs do actually have continuity with the actual the frame of the transformer. So I'm actually going to go back to ohms. Ohms on here, haven't we? Oh. Probably help if I got the right terminals in. There we go, got there eventually. So let's just check we've got good continuity. Which actually we haven't got. Oh, we have. You see that? So I'm just checking that where I'm going to do some resistance checks between the framework. I just want to make sure that the framework here is actually connected to these bolts. I think it might have a little bit of varnish on it or something. Yeah, we might actually have a little bit of varnish on there or something. Okay, that's it. We've got a good contact now. So I'm going to do the insulation resistance test now. Whenever you use an insulation meter, the first thing you actually do is before you do the test, you actually check the meter's working. So we're looking for a fail. So, okay, there's a fail because we've got a short circuit to the frame. You always prove that. So let's go to the secondary. Now we know that the secondary winding, although it is centre tapped, it is one continuous winding because we checked for that earlier. So, okay, so you can see we're actually clear at 1000 volts. Sorry, yeah, clear at 500 volts. I've got no doubt we'll also be clear at 1000, which we are. Not actually sure what the maximum reading is on this particular meter. I think it might be a couple of hundred megs. The AVO I've got goes to 1 gig, but I'm not dead sure about this. Okay, so that is the... So we've now checked that we've got no resistance between the secondary winding and the actual framework of the transformer. We're going to do the same for the primary winding now. Okay, so we are actually showing a little bit of resistance, but again, it's in excess of, what's that one? I think that's 1100 meg ohms, isn't it? 1 gig. Just try it at 500. Yeah, it's clear at 500. So, okay, I'm fairly pleased that there is no leakage between either the primary or the secondary to the framework of the transformer. So the next test that I'm going to do is I'm going to look for leakage between the secondary and the primary windings. That's a beer. Okay, and that's clear at 500 volts. Let's push it a little bit higher. Yeah, and it's also clear at 1000 volts. So in terms of insulation resistance, this transformer looks good. We've got no short circuits between primary and secondary. We've got no short circuits or no low resistance between primary, secondary and the framework of the transformer. So that's looking fairly good. Do you want to say any more? Do you want to see me put power on this transformer? Are we bored with this and want to have a look at the stereo multiplexer? That'd be easy. I'll just catch up on the chat. Yeah, Sheffield. I think people have mentioned hole in the road in Sheffield. I mean, I work in Sheffield, but I don't actually know what the hole in the road is. I don't. Somebody did send me pictures of it once, but yeah, I don't know what the hole in the road is. Is the hole in the road still there? I don't know. I haven't been to J Burkitt's in Lincoln. A lot of people have told me about it, and I keep saying to my good lady wife that I would really like a trip out to Lincoln. And of course, what I don't say is because I want to go and visit J Burkitt's. But I believe it's somewhat of an Aladdin's cave. Has anybody been recently to Burkitt's? He is somewhat of a legend, isn't he? I think he must be in his 80s now, but yeah, he used to certainly have a lot of interesting surplus stuff. The hole in the road, the massive fish tank. Again, I don't know what the fish tank said. Sorry, I don't know about the fish tank. Oh, I think Paul's just sent me a link to that. What's the transformer out of? I've got absolutely no idea. Oh, Benji's just saying that he used to rummage through the damaged stock bins. I used to do that as well. But the stuff still wasn't super cheap, was it? Even when you got it out of the damage bin. But yeah, I remember buying little bits of transistor radios, and I think the odd tap meter that came out of the damage bin. And I did used to take them home and repair them, but I don't remember them being super good value. Yeah, happy days though. You want to see me rummaging through my drawers? I did think about doing a video about that because, strangely enough, other engineers do like to look around other people's workshops, don't you? Even though it's like commonplace to me, who's in every day. You know, you probably would like to rummage down around some of my component drawers. I mean, if I were to look up on this side, I've probably got every variation of the Z80 processor and every type of memory chip that was ever commonly used because that's what I used to work with back in the day. Except I haven't opened some of these drawers in front of me for more than 20 years. I'm sure that some of you vintage processor freaks would probably enjoy that. I can just see, you can see some Z80s and some Motorola 68,000s there, and various support chips and RAM ICs. So yeah, maybe I'll do a tour of my component drawers one day. I have got a mug that you sent me, Benji, and I do use it, but this is a vintage steel mug from one of my friends, Andy, who I think you've seen Andy's channel. Andy has got the American trucks. Of course, I've got an American truck as well, my Chevy, but Andy's got American trucks, and he's got a little YouTube channel where he does various things. And nice bloke, Andy. So I think you probably watched his channel as well. Used to go to Sheffield Arena. Oh yeah, I forget. Ian used to be a biker, didn't he? Yeah. Oh right, okay. So Victor's saying that he was at Burkitt's a couple of years ago, and he was over 90 then. Wow. Yeah, well, if you have a shot of Z80s, Scott, I've got drawers and drawers full of them. I'm waiting for them to become collectible, and then that's what I'm waiting for. And then I'm going to retire to my desert island on the money that I make from selling Z80A processors. I think we might have a long wait, but yeah, I'm sure they'll become valuable at some point. I've got so many support ICs and what was it, PIO trips, parallel interfaces, and all that good stuff. I used to do a lot with Z80s. I say a lot, I did a fair amount with them, but I moved on fairly quickly to using microcontrollers. I used to use the 8051 a lot. I did a little bit with some of the Hitachi 8H processors. What else could I talk? And then kind of PIC chips, but I never used any of the very advanced PIC chips. I was kind of doing pretty basic control applications and bit banging. So yeah, I used PICs, but certainly some of my probably more of my working career was spent using 8051 microprocessors with CAN bus interfaces. I used to do a lot with CAN bus, but again, God, we're talking 20 years ago now. Oh, Graham's setting the stream up for this afternoon. Okay. I'm just the warm up. Of course, I'm just Graham's warm up act. So, yeah. Okay. Does anybody? I don't think any of you want to see this transformer powered up, and I don't blame you because that's quite boring, isn't it? It's a transformer. So I will power this up off camera, and we will see if it works, or I'll see if it works anyway. I'm sure it will because the testing that we've just done is a good predictor. So let me have a swig of tea, and then we'll get the next box on the bench, and the next one is a bit of a mystery one. Because I bought it that long ago. It's a stereo multiplexer unit, but I bought it that long ago. I can't remember what it is, who made it, where it came from. It's been in this box here and open for 3 or 4 years. So I'm hoping that if I shout out what the make and model number is, one of you can go away, Google it, see if we can download a PDF, and you could maybe shout instructions at me when we try and set this thing up. Assuming it works, it might not work, but we'll plug it in and we'll give it a go because I've got no idea how you work the thing. I don't do a lot with stereo. In fact, I don't really do much with FM. I mean, I have worked on FM radios, but yeah, it's not something I'm massively into. And stereo, I'm not really into my hi-fi equipment. I've said to you before, I don't own any music. I don't have any records or CDs. I don't listen to music, so FM just really isn't very useful to me. I think the actual FM signal is relatively, sorry, the FM stereo multiplex signal is relatively complicated. It's got a number of pilot tones and suppressed carriers, and it's also got both information in the left and right sidebands, and also it's interesting that it can be received via, just a traditional receiver, because that was part of the original specification when people came up with stereo, that you had to be able to receive stereo on a mono set. So it's kind of quite clever that the way that it was actually invented, and I'm going to call it an American idea. Although I would suggest that lots of people were doing works on both FM modulation. So American, I think it's a chap, Colonel somebody or other in America, that was attributed to producing the first FM signal back in, I think it was around 1938. But I would actually say there is some argument about that, whether or not he was the first to produce FM. But he also went on to do a lot of work with what I would call multiplexing of radio signals. But most of his work on multiplexing was done on AM rather than FM. Right, okay, so here's the first big box. There we go. Somebody's put the name up. Colonel. No, it wasn't Colonel. It wasn't Colonel Sanders, was it? I think I wrote it down because, you know, when you watch us YouTubers, some of us you say, "Oh, you're smart. You know all these things." Well, we're not smart. What we do is we prepare in advance, and we actually get notes on it. So I did actually make some notes. Edwin Armstrong, 1933. So the first FM signal was broadcast by Edward Armstrong. It was the first wideband FM signal in 1933. I would dispute that because I believe the BBC were also doing work on FM at around the same time, but I'm not certain. But he did also do a lot of work on multiplexing of signals. I think he was mainly doing multiplexing of AM signals rather than FM signals. I did also print off a little picture of what the actual frequency, what the frequency of the modulated waveform looks for. So you have a pilot tone at 19 kilohertz, and then you've got a sideband with left and right, which is, I believe, what your mono receiver pulls into, and then you have left and right sidebands at the other side here. I think that these would have a pilot tone at 38 kilohertz, but it's actually suppressed. So you can actually see that they filter out the 38 kilohertz carrier, and you actually use the 19 kilohertz. If you time 19 kilohertz by 2, you get 38 kilohertz. So they actually use a pilot tone at 19 kilohertz to actually resolve the sideband information. Okay, so I'm going to get out my depth fairly quickly with that. As I say, I don't know much about FM. I do hope that this box hasn't been, this unit hasn't been smashed, because because it's been sitting in my hallway for about 4 years. Maybe the cat's weed on it at some point, wouldn't surprise me. Weeds on everything else. Well, it feels quite well wrapped. Let me just check the chat. Z80 CTCS are quite pricey, are they? I've got some, yeah. Do you have a favourite song though? No, I don't. No, I don't do music. I like spoken word. I was always enthralled by, as a young lad, listening to radio ham broadcasts and CW transmission and things like the British World Service. I've never been interested in music. I don't listen to it. Yeah, left minus right and left plus right. That's quite right. Yeah, someone's mentioning ring modulators there. Diode ring modulators, was it? Was it diode ring? Was it transformer ring? Again, I'm having to think back now. I have to think back 30 years from when I did my degree in comms engineering. Oh, that's quite a heavy unit. I'm just going to put it on the floor, move the box out of the way, and then we'll take a look at it. Just having a look through the packaging, just make sure there isn't a manual in here. No, we don't have a manual. So just have a bail stand. Let's look for a manufacturer's number. Oh, it is a well-known make. I don't know how to pronounce it, but it is a Meguro, Meguro. So they do still. I don't know if they're still going to this day, but they are quite a famous maker of these stereo multiplexers. So that's the manufacturer, right? I'm going to get the model number so you can start Googling. So the model number is MSG-211F. So that's a Meguro MSG-211F. Let me hold it up to the camera. Just notice that on my screen everything looks backwards. Does it look backwards to you? I'm not sure. It looks backwards to me. Can you read that? Closer up, please. If you look at the back panel, I don't think there's much on the back panel. Looks like we've got a voltage selector switch, but I'm fairly sure it's going to be set to the UK because it's got a UK mains plug on it. So this is really where, if I could have remembered what I'd actually purchased, it would have been useful, wouldn't it, for me to actually download the manual, so I would actually have some idea of knowing how to set this up, because I've got no idea how to set it up. So let's just have a look at some of the inputs on it. I think the first thing that we might have problems with, maybe this will be for another video, because I'm not even sure how I have some jack plugs to set this up. So we've got external modulation input here. So it's got left and right channels. So we need a source of stereo here for left and right. Now I have actually got signal generators, but I think it might just take me a little bit long to set them up today. But what we could probably do is set up 2 signal generators, maybe have the left tone at like 800 hertz and the right side at 1 kilohertz, and then we could actually hear the difference between the left and the right. But certainly it's got the left and right channel inputs here. We've also got something called the audio oscillator input, so I'm not sure what that will do, don't know. I can see that we've got some preset switches here which say, and I think these must be to do with the pilot tone, because they say level. So we've got a level, a phase, a scope phasing, and a meter zero control. We can set internal and I think external pilot tones. Again, not really sure what some of these things do. So we've got audio oscillator left, audio oscillator right, or sub, which I'm guessing is maybe sub carrier, could be. Looking at some of the other input switches here, we've got audio input internal or external. So again, we've got some internal generators here. So we've got a 400 and a 1000 hertz audio modulation setting. So it looks like we don't have to use external modulation. It has actually got an internal one. We've got a control down here which is FM. So this is, sorry, we've got pre-emphasis and de-emphasis. Well, sorry, it's pre-emphasis. So I think this, does that boost the treble or does it boost bass? I cannot quite remember. I think it boosts the treble, doesn't it? And then you actually reduce it back down at the radio and you de-emphasize it. I'm not sure. Again, not an expert on FM transmission, but I think that's some form of filter, isn't it? Pre-emphasis, de-emphasis. We've got the output here, which is a 600 ohm output, and then we've also got something called the pilot. Now, my understanding, if I was to guess how this operates, start again. So this unit is only a stereo multiplexer. One thing that it isn't is it isn't a transmitter. So this won't actually transmit the FM. What we'd actually have to do is connect this unit up to the signal generator. So I've got an RF signal generator on the bench next to me. And what we'd actually have to do is we have to modulate the input signal. We have to turn it into a stereo signal. We'll have to output that stereo signal, that modulated stereo signal. So we take the modulated output from this Maguru device. That has to go to the modulation input of the signal generator. The signal generator is going to then FM modulate a carrier wave at whatever frequency we want to work at, maybe 100 megahertz. And the signal generator will transmit it just locally within this room. And in theory, we could use this radio to actually pick it up. But maybe we need to find a manual. Has anybody managed to find a manual for it? Because I kind of think that if we haven't got a manual, we'll just be wasting a lot of time guessing and pressing buttons. Yeah, saying it was long enough to be sent by Royal Mail. Yeah, 4 years. You'd think they could have sent it. Could we see it on the spectrum analyzer? Possibly. Tell you what, let's see if the reefer cap explodes, shall we? It's got a mains plug on it. It's got a 3 amp fuse in it. It's either going to work or it isn't. It hasn't been stored in a wet place, so in theory it shouldn't explode. Any bets? Is it going to explode and the power's going to go off, or is it going to work? Any ideas? No, I'm going to switch it on. If everything goes off, we know that we know my earth leakage circuit breaker's tripped out, and I will see you next week. Here we go, on. Well, okay. Got some movement on the meter. See that's bobbing around. It appears that we've got a variable resistance here which says composite level. So I guess this is something to do with the output level of the modulated signal. I guess the other problem is that this is a radio that I was going to use to pick it up, and because again, I don't have any stereo radios. Now this radio is stereo, but it only has a mono speaker. It's only got one speaker in it, but it does pick up FM stereo. I think I could plug some headphones into it, but you're not exactly going to get the viewing pleasure, are you, by watching me with headphones on? But I think that's probably what we'll have to do. I wonder, does YouTube even transmit in stereo? I'm not sure. Okay, so we haven't let any magic smoke out, so I'm taking that as a good sign. But unfortunately, this unit is somewhat bereft for flashing LEDs and digital meters, and well, it's a bit disappointing, actually, isn't it? Yeah, a bit disappointing. Well, the other thing I can think to do is let's try and plug it into the signal generator. Okay, let's switch the signal generator on. I'm going to pull you up. So let's try and find a little bit of space on the FM band that's free. Right, 90 megahertz is free where I live. If anybody's watching, better not tell Ofcom. Okay, there's 90 megahertz. Let's go for a relatively high RF level. So we should have a carrier there. We need a bit of wire, don't we? Just rummaging through my drawers for a little piece of wire I can use as an antenna. I can hear we are picking some stuff up there. Actually, will that work? Okay, so hopefully we can hear that. That's at full volume, so we're not actually picking very much up there. Okay, I've just increased our FM deviation a little bit there. So, tell you what, I'll tune in to 90 megahertz, and can you hear a pilot tone? Oops. Let's turn the output power down a little bit because we want to be careful. Don't want to disturb anybody. Okay, we've got a signal there of minus 30 dBm. So, is that bothering you? Should we turn that down? Anyway, so you can hear we've got a pilot tone there, but of course that's a mono signal that we're picking up. Well, it appears that my logic analyzer, my spectrum analyzer, isn't plugged in at the moment. I'm afraid I have to reach down under the bench to actually switch that on, so maybe we'll try that another time. So what we need to do now is, I think we need to get the modulated signal out of this device and into the Marconi, which is acting as our transmitter there. So my first problem is it's got a jack plug on it, which would that be? I'm guessing it would be a mono jack plug. Don't know if I've got a mono jack plug, so let me go through my lead collection. Nope, not that one there. There we go. We've got a stereo jack plug. Now I think that we want the 600 ohm output, don't we? I think that's what we need. I think we need to connect that to the modulation input of our Marconi, which is our transmitter. Tell you what, I would give my kingdom for a BNC lead. There we go. Ah, damn, I just accidentally switched the meter off. Switched the transmitter off. Why did I do that? Put my thumb on it. So I have to start up again. Any of you still watching? It probably doesn't make for great entertainment, this, does it? Watching somebody fail to be able to work a piece of test equipment. Right, okay, so I think that this output will be outputting our stereo multiplex signal now. So in theory, we've got the output from the signal generator. Shall I move this back a little bit? And maybe you can see it. So we've got the output from the multiplexer. I've got that connected to the input of the transmitter, and that's going into the mod in. So I think we need to select external modulation, don't we? Oh, right, okay, so this is where I might have been defeated already. So definitely can hear the signal there. How do we select external mod in? There we go. Okay, so can you hear that? So, all right, okay. I think we might have two signals there, and they're beating with each other. I think that's our left and right. Can you hear that? Scott's saying that the reefer's going to blow up in 5 or 10 minutes. Have you set a stopwatch? I'm not doubting you, Scott. You are probably right. What I need to do now is plug some headphones in, don't I, and see if we are actually getting stereo. This makes for great video, doesn't it? Well, I'm hearing it in both ears at the moment. I've got the signal in both ears at the moment. No, at the moment I'm getting it in both ears at an equal level. Does this radio have to be set into stereo? I reckon in FM it should be stereo automatically, shouldn't it? Anybody know? Anybody use one of these? It's going to be in stereo. Whenever you select FM, it's going to automatically go to stereo, isn't it? It's not going to be in mono. I thought what we were going to be able to hear is I thought we would be able to shift the sound from left to right, but maybe the actual internal modulation control here, maybe it's actually applying this internal tone to left and right equally. I thought we might be able to, shift to the left channel or the right channel. I can't see any option of doing that. The only thing I think we could do is if we could get a signal plugged into here, left or right. So I'm going to take a short break. I'll be back with you in a minute and we'll connect a signal generator up there to here. Although I think we're going to run out of test leads. Yeah, the radio only has one speaker, so I'm listening to it through headphones. But I'm getting the same level of volume in both the left and the right ears at the moment. I think probably what I've got to do is I think we've probably got to use these external modulation inputs because I've got a feeling that well, obviously, if we supply an audio tone into the left channel, hopefully we won't hear it on the right headphone and vice versa. So I think we need to squirt something into there. Okay, so I've got a 1 volt, quite a high signal, 1 volt, 1 kilohertz. Let's go for 800 hertz, it's less annoying. Right. I think we're going to be struggling again for another stereo jack plug, sorry, another mono jack plug in that size. This is going to be kind of patch cables, patching patch cables. That might work. Right, okay, let's give that a try. Well, I'm afraid a little bit of a fail. We're going to have to try and get a manual for this or get some advice. So again, I'm inputting the tone into the left channel now, but I can actually hear it coming out of the right and left headphones. So I'm fairly sure that we should actually be getting it just on the left channel at the moment, but we're not getting that. But of course, I could have something just set up totally wrongly. I don't know. I'm going to have to read the manual, I think. So I do think I think we'll probably have to call that a day there, because I'm going to have to do some reading or maybe just get some advice on how to set this up. So we're definitely working there. We are transmitting a tone. I can actually hear the tone from my signal generator. I will just try the. Also, just wondered if this Heil headset is stereo, but it is. It's not got a mono switch on it, has it? It's got a phase or out. I think that's just a filter, isn't it? No, unfortunately, I'm just getting a combined stereo output there, so a bit of a fail. The unit is definitely working. I suspect we've just got something that isn't set right, or maybe this radio isn't receiving in stereo, although I think it would be, wouldn't it? Maybe I just need to find a simpler radio that's got two speakers on it. But it does say stereo. It says on the front of the radio that it is FM stereo, so I'm guessing that it is FM stereo. Just make sure there's no mono switch selected anywhere. Just wondered if the set gives an indication when I tune into another stereo signal.
All my three children are hopefully. I know them. So much, David. We'll catch you next week.
Well, it's not fantasy. The artist has many symbols and very serious. It's not just an art. It's like.
I don't think it has a stereo indicator, this radio. I think it has a tuning indicator, but I don't think that's a stereo indicator, is it?
Sure.
It would be useful, wouldn't it, if I had one of those old hi-fi units, an old stereo tuner, because they actually used to have a lamp on them that I think used to come on, didn't it, when it detected a stereo signal. But unfortunately, I don't have one of them. So a bit of a fail there. So I don't know if my test setup is wrong or if this signal generator is wrong. I think the signal generator is working correctly, and I think it's just me that doesn't know how to work it properly. I think that's most likely the problem. So I think rather than just pressing buttons, old blokey, thanks very much for watching. Just going there. Cheers. See you later. I think rather than just pressing buttons for the next hour, what I need to do is off camera. What I'll do is I'll play around with this, and when I've sussed it out, I'll bring you back on another live stream in the future, and I'll give you a demo, and maybe I'll have a suitable radio so that we can actually see the stereo going left and right. And again, we'll get the spectrum analyzer out and we'll have a look at the stereo multiplex signals. We'll have a look at the carriers and the pilots, and we'll do a feature on that if anybody's interested. But before I do that, I've obviously got to go away and learn a little bit more about what I'm doing. So I think to end with, we're going to do what we said we were going to do. You said you wanted me to see me charge up this capacitor. So let's charge up this capacitor and discharge it. Yeah, you should be able to see it on the spectrum analyzer. Unfortunately, it's not plugged in, and I can't get at it under my bench to plug it in at the moment. I was using the communication analyzer the other day, so I had to unplug the spectrum analyzer and plug that in. What I'll do is, off camera, I will play with this later today. And I think I might have got an old stereo radio in the garage somewhere. So what I'll do is I'll go and see if I can dig that old stereo. It's one of them old ghetto blaster things from the 1980s. I'll bring that in, and I think that might have one of those stereo LED indicator lamps on it. So we'll give that a try and yeah, see if we can get it working. Is the cat still about? No, the cat's not about. You may have to recap the old ghetto blaster. Yeah. And that's definitely been stored in a damp garage for the last 20 years. Is that a neon tester? Where are you looking? I don't know where you're looking. Is it a neon tester? I've got some neon screwdrivers, but have I got one on the bench? I can't see one. Right. I've got to warn you in advance, it never looks very impressive when you discharge these things on cameras because the camera doesn't catch it, and the volume control and the microphone, it always kind of backs down, so you never actually get to see the real effect. It's always a lot more frightening to witness it in real life than it is when you're when you're actually watching it on camera. Okay, there's 6,000 volts. I'm just going to turn my generator up a bit higher. 12,000 volts. Okay, can you see that? Oops. 1,000 volts. 2,000 volts. 3,000 volts. I'm actually going to stop at 4,000 volts because I know that that's pretty bad as it is. Right, we're at 4,000 volts, and my room, it now stinks of ozone. I can actually smell that. It's a really horrible smell. Are you ready, everybody? Jesus. Did that actually come out? Last time, and then we go in. Any damage to the screwdriver? I don't know. We'll have a closer look next time. Right, can you see that? I think you can see everything. Here we go. Yeah, you won't see it. There is a little burn mark in the end of the screwdriver, but it's not pitted it. It's it actually has. It's actually it's taken a little chunk out of the end of this screwdriver. So yeah, unfortunately, you're not going to see. Right, I don't know if you saw that. I then put the screwdriver across again. We got another crack. So that just shows you that although we did discharge that capacitor, it's actually come back a little bit just from sitting there for a few moments. And that's one of the reasons that these high voltage capacitors can be so dangerous. You can discharge them like this, but they will actually reform themselves. The dielectric absorption, it will still release enough charge, whatever happens. I don't understand the physics, but basically the charge will reform. Even when you've discharged it, the charge will reform, and it could still reform into a voltage which is lethal, could still kill you. So dangerous things not to be played with. I did actually make a video on building this ESD gun, and sorry, SDG, your name's just gone out of my head. I'm really sorry, but if you actually look at the SDD channel, he actually built, I think, an ESD gun as well of some description, and we did have a chat about these at the time. So I did actually build this on my channel. It's all fully 3D printed, and I think I did release all the circuit board information and stuff like that if anybody's interested. Did you not finish it? Well, I know what that's like. You know, we move on to other things, don't we? But I was actually quite pleased with this. I would actually like to do more on this channel about testing. I'm not doing very well today. Electromagnetic compatibility, that's something which I am interested in, and quite often at work it's me that takes our products for EMC testing, so I've done a fair amount of it, and I also do some of the pre-compliance testing of the equipment at work. So I would like to build up a little bit of equipment so that I could do some more pre-compliance testing at home. So maybe we'll do more of that test equipment in the future. But I think for today, I'm sorry, let me move the camera up. I think for today, that'll probably do. I'm sorry we didn't get the stereo multiplexer working. That's a bit of a shame, isn't it? I'm sure we will get it working, but I've just got to go away and find a little bit more about how it works. But yeah, that's for another time. So it's been a bit of a long episode today. So as always, thanks very much for taking some time out of your Sunday to join me. It's been an absolute pleasure, as always, to see you here. I thank you for coming. But I guess for today, that'll do. Thanks very much, everybody. And I hope to see you again very soon. But until then, bye-bye for now. Scott says night. Yeah, night. Bye, Andrew. Bye, Dave. Bye, Colin. Bye, Mac. GN Nuja. Bretsky, thanks. Oh, Man Cave Workshop. Hello, Sean. Just crept in under the bar there. Okay. Thanks very much, everybody. Hope to see you again very soon. Bye for now. Bye.